So today we will be talking about biological oxidation of alcohols. So we will be discussing how alcohol is metabolized in the body. So as an example, I picked ethanol, which is a molecule depicted right here. And the reason I picked it is because this alcohol is the most relevant to us humans. So the reaction that you see in front of you is a summary of what happens when we have a drink. When we're at a party and we feel good about ourselves, it's because we're ingesting ethanol. But as the night progresses, ethanol gets oxidized to this compound right here called acetaldehyde. Acetaldehyde builds up in our body, and this compound is responsible for this very unpleasant feeling of hangover that one feels the following morning. So this oxidation is catalyzed by an enzyme called alcohol dehydrogenase, abbreviated ADH. And this enzyme needs a molecule helper, which is called coenzyme or cofactor. This molecule depicted right here, which is called nicotinamide adenine dinucleotide, abbreviated NAD+. Now, it's a large molecule, so you can deduce from the name it's a dinucleotide. So it's adenine, so it's also connected to one of the DNA base pairs. But that portion of the molecule does not participate in this process. So I abbreviated it as R. And all action takes place in this portion of the molecule, which is drawn right here, which is nicotinamide. So it's abbreviated NAD+. And so since ethanol gets reduced, and we can see that we started with a single bond between carbon and oxygen, and now we formed two bonds between carbon and oxygen. So this carbon went up in oxidation state, right? And it lost a pair of electrons, because oxidation is the removal of electrons. And if something gets oxidized, as general chemistry teaches us, then something else has to get reduced. So in this case, it's NAD+ that gets reduced to this molecule, which is now called NADH, and it picks up a pair of electrons and a hydrogen and forms this new carbon-hydrogen bond. So it gets reduced. So let's color code the new bonds that we formed. So we formed here an additional bond between carbon and oxygen, and it's going to be red. And then here we formed a new bond between carbon and hydrogen, right here. So next, we will look at the detailed mechanism to understand how this transformation takes place. Now, you may recall from organic chemistry that a lot of reactions are catalyzed by a metal or a metal complex. There is no exception here. Alcohol dehydrogenase belongs to a class of enzymes called metalloenzymes. And the reason for that is because it contains zinc in one of its domains. And what zinc does here is it acts as a Lewis acid. So we have a lone pair on this oxygen. And so zinc accepts this electron pair. The definition of Lewis acid is that it's an electron pair acceptor. And you can think of it as zinc basically tagging on that lone pair. And what it accomplishes is that now this bond between oxygen and hydrogen is now weakened. The pK of this hydrogen is lowered. And so it's easier for a weak base, such as water, to pull off that proton. And so now we have this new intermediate. So I will draw out this hydrogen, and you'll see in a second why. Okay, so now let's look at what is happening with our NAD+. So here we have aromatic ring, and you may recall that aromatic ring has different resonance forms. So we can push arrows around the ring like this, and now place these electrons onto nitrogen. And so in our new resonance form, nitrogen becomes neutral. We still have this amide bond right here. But now the positive charge resides on this carbon. So in the next step of the mechanism, what we will see, it's called concerted mechanism, meaning that all the steps will happen at the same time. So these electrons will come onto here to form a new bond between carbon and oxygen. But since carbon can only have 4 bonds, something has to go. So this hydrogen, together with its electrons, will form a new bond right here. Now, as I said in the beginning, this enzyme that catalyzes this reaction is called alcohol dehydrogenase, meaning removal of the hydrogen, which is exactly what we observe here. So now let's draw out our products. So there's this product, which is acetaldehyde, and the new molecule, which is NADH. So let's draw that out as well. Okay, our group right here. This hydrogen right here. And so here I'll just write out a name so you guys remember. Okay, let's color code our new bonds again, just like we did in the beginning. So we have this new bond between carbon and oxygen, and the new bond between carbon and hydrogen. So to summarize, in biological oxidations of alcohols, alcohol is oxidized to an aldehyde. The process is catalyzed by an enzyme called alcohol dehydrogenase, and during this process, NAD+ gets reduced to NADH.